Hello everybody, in this presentation we are going to learn how we get to name organic compound. We will be able to understand what a primary carbon is, what an alpha carbon is, what a secondary carbon is, what a tertiary and quaternary carbons are. Alright, so looking at this structure, before you get to name any compound in organic chemistry, you have to first identify the functional group to that compound. In previous presentation, we talked about functional groups, but don't worry, we'll still discuss this in class, but it is important you learn and understand these things before the lecture day. All right, so now if you look closely, you can see the OH, and we know that the OH is the alcoholic functional group, so we know definitely that this compound is an alcohol. All right, so the next thing you're going to do is to count the number of carbon atoms on the structure, the longest carbon chain. All right, so now if I get to start counting, let me assume that this is going to be my first carbon. If this is one carbon, remember we want to know the longest chain possible. So if this is 1, let's take this to be the second, and this 3, this is the 4th. You see, we have excluded this carbon, we have also excluded this carbon, so it means that we can't go towards this route. So we can't go towards this route. So we are going to count again. All right, so if this is 1, this is 2, let's say this is 3. Now let's count this as 4. You see, now let's count the next one as 5. Can you see? That's to tell you that I've probably counted the longest chain possible. 1, 2, 3, 4, 5, right? 1, 2, 3, 4. I can still go to this one. That means I would remove this one. It's still the same thing. Can you see that? So the longest chain is 5. The number of carbon atoms we've counted so far is 5. Now, for convenience, I'm going to denote this one to be my 5th, so that it goes just straight like that. So our longest chain went this way. All right, so in that case, since we've been able to identify our longest chain to be 5, now it's going to be called a penta because 5 stands for penta. All right, 6 stands for hexa. As you can see, I've just displayed over there. So since we know that this compound is a penta, all right, so we will now proceed. The next thing we are going to do, remember the first thing we did was to identify the functional group. Then you have to count the longest chain possible, right? Now, next thing you're going to consider is you have to now look what is the shortest carbon counting to the functional group, which is this. What is the shortest distance or shortest count to the functional group? If I should start, since I've identified my longest to be 5, if I start from here, if I say here is 1, and here is 2, and here is 3, it means that my functional group is on the 3rd carbon, right? Which is okay, but let's count the opposite. So you have to also count the opposite. Count it from the other way around. Remember, still maintain the position that you've counted 5. So I'm going to start counting from here instead. So 1, here's 2, here's 3. You see, it still tells me that the functional group is still on the 3rd. So we've confirmed that the shortest distance or the shortest number of carbon atoms counting to the functional group is 3. So it means that this is a 3-pentanol. Can you see that? Now, this 3-pentanol is pentan. You can write it. If you don't want to write 3-pentanol, you can write pentan 3-ol. All right. So now this is what is called parent name. So the parent name to this compound is 3-pentanol. Can you see that? So the shortest distance or the shortest carbon counting to the functional group will tell you the number you're going to attach to the parent name, which is pentanol. All right. So once you've achieved that, You also check now what is the shortest distance to the substituent. Now, how do you determine that? Now, if you look closely, any other carbon that we did not count is considered as a substituent. Now, I'm going to start counting from here. This is 1, this is 2, remember, this is 3, and I have to wipe this place off. And this is 4, right? This is 4, and this is 5, right? Now, since we've all agreed that the functional group is on the third carbon, which you can see here, now you have to also count the shortest distance to the substituent. Like I said, any of the carbon atoms you did not count is considered a substituent. If this is 1, this is 2, it means that I did not count this, I did not count this. So that means they are substituents. When I went to the third carbon here, you will get to see or notice that I did not count this. So this is another substituent. We have 3 substituents. Now, you have to also consider the shortest distance to the substituent. Since here is the first carbon, now the substituent is on the second. Can you see? On the second, right? So that is good. Now, if I should start counting from this end to say that this particular carbon is 1, and here is 2, and here is 3, it means that the shortest distance to the substituent is also going to be 3 here. But then, look at this. There's another substituent here. But then, we are not going to consider this one because this other substituent is on the second. Can you see? The double substituent here is on the second carbon. While if you start counting from the top here, if you start counting from the top, right, the substituent is going to be on the third. Can you see? So that means we are not going to count towards the carbon whose substituent is on the third. Instead, we are going to count from this substituent whose carbon substituent is on the second. All right. So that is just the idea I need you guys to understand. So I'm going to wipe all this. Now, as you can see clearly that our substituent is on the second carbon, 2 of them on the second carbon, while if you go further, there's another substituent on the third. If you start counting from the top here, 1, 2, 3, the substituent is still on the third. So we will not go through this route. We will not start counting from the top here. Instead, we will not count from the top here. Instead, we will start counting from this bottom, such that we will give the substituents, which are these 2 substituents, the shortest number possible. Now, if you look closely, on the second carbon, we have 2 substituents, one on the left and one on the right. The name of the substituent is CH3, which is methyl. The other substituent is the same methyl. So on the second, we have a methyl. On the second, we also have a methyl, 2 of them. So if we want to name this, it's going to be 2,2,2-dimethyl. Can you see? Now, if we go further, right, we go to the third, there's no methyl. Of course, there's a methyl, which is this one, right? So we are having 1 methyl, which is on the third. So we have 3 methyl. It's just one of it. Okay? Can you see that? So once we've got to this stage, and be sure that we've gone through all the substituents and we are left with no other substituent, then we are ready to name completely this compound. All right. So, and if we want to name it, we have to name it checking or counting the total number of substituents. Now, in this example, the substituents are actually the same. They are actually the same. So we would not be considering alphabetical ordering that I would discuss in class with some other example. All right. So if we want to, how many methyl? You see, we all have methyl, right? So we have 1, 2, 3. 3 methyl groups as a whole in totality. So I'm going to have 2, I'm going to write the numbering, their positions, 2, 2, another one is on the third. What is their collective name? Their methyl group, so it's going to be tri, because there are 3 of them. Trimethyl. Can you see? 1, this is the 1 methyl, this is the 2nd methyl, this is the 3rd methyl. All right, so we have 3 methyl groups, so it's going to be 2, 2, 3 trimethyl. What is the parent name? Once you've named the substituent, you now add the parent name. The parent name we got was 3-pentanol. So we're going to have, or just write 3-pentanol. All right. So that is to tell you that the name of this compound is 2,2,3-trimethyl 3-pentanol, or you can say 2,2,3-trimethyl pentan 3-ol. Can you see? That is how we name these compounds. Now, one last thing I need you to understand is for the fact that you have to know the nature or degree of the carbons. Degree of the carbons tells you for a particular carbon how many carbon atoms are attached directly to it. If you see a carbon that is attached to only one carbon, we say that carbon is a primary carbon, which we designate using the symbol. If you see a carbon atom attached to 2 carbon atoms, right? All right, we say that that carbon atom is a secondary carbon. So if it is a carbon atom attached to 3 different carbons, we say it's a tertiary. If it is 1 carbon attached to 4 different atoms, we say it's quaternary. Now you can take a look at this structure yet again. This is the first carbon, right? Let's take this to be the first carbon, right? Now this carbon alone, which I've just highlighted, is connected or attached directly to this carbon, and it is the only carbon this particular carbon is attached to. So we would say that this carbon is a primary carbon. A primary carbon, because it is attached to only 1 carbon, which is this carbon. Can you see that? So we call that carbon a primary carbon. Now let's take a look at this carbon over here. What kind of carbon is this? Now this carbon highlighted is attached directly to this carbon. It's also attached directly to this carbon, meaning it is attached to 2 different carbons. So we say that this carbon just highlighted is a secondary carbon. So this is a secondary carbon. Now let's look closely to the next carbon over here, this particular carbon. What kind of carbon is it? If you look closely again, this carbon is attached to this carbon. It's also attached to this carbon and also attached to this carbon. So since it is attached to 3 different carbons, we would say that this carbon is a tertiary carbon. So let's have a tertiary carbon. Can you see that? Now let's look closely again if we want to check to know what all the carbons, their degrees are. This carbon, I believe you already know, this carbon is directly attached only to this carbon. So just 1 carbon attached to it makes it a primary carbon. So here we have a primary carbon. Can you see? Now finally, let's look at this carbon. What kind of carbon is this? This carbon is attached to this carbon. It's attached to this carbon, also attached to this carbon, and finally to this carbon. So this carbon alone is attached to 4 carbon atoms. So we call this a quaternary carbon. So this is how you get to know the degree of carbon: primary, secondary, tertiary, and quaternary carbon. And finally, you need to know that the carbon directly attached to the functional group, which carbon is that? This carbon. So that's to tell you that this carbon is called an alpha carbon. Alpha carbon is the carbon attached directly to the functional group, which you can see here. This is the functional group. Can you see? So that is how you identify an alpha carbon. All right. So we would end this presentation here such that you go through and understand these things. We'll meet in class and then I will have to explain this thing further.